Hi everyone, it's Emma back with another video for GCSE Chemistry, mainly aimed at WJEC, but I think the videos I've done so far cover any specification, whether you're doing AQA or edexcel. So today we are going to look more at the subatomic particles. Now that's a fancy word or a phrase, I guess, a term. Remember, it's the ingredients that are inside the atom. There are 3 in total, and they are called protons, neutrons, and electrons. You've got to know some more information about them. So we've spoken about where they live. Everything lives in the middle, which is the nucleus, except for the electrons. And you've got to know how many of each ingredient are in every element. So how many are in oxygen, how many are in nitrogen, how many are in potassium, and you'll use your periodic table for that. I've got a periodic table coming tonight, so, well, hopefully my sister doesn't let me down. But I have got a little bit of a gadget today, a whiteboard, so hopefully you can see my writing a little bit more. It's dreadful, but I'll try. So you need to know the relative masses and the relative charges of the 3 ingredients of the protons, neutrons and electrons. And we say relative because they're just compared to each other. They, like, atoms are tiny. Like, in that full stop, there will be millions and billions of atoms, all right? So we're just going to try and get our head around it. There's no point in us trying to think of the scale, but if we were to think of an atom and the subatomic particles, we're looking at the masses compared to each other. Now, I hope that you've heard the word mass before and you think weight. How much does something weigh? And it's not technically right saying that mass is the same as weight, but if you can relate mass to weight, it's better than not knowing what mass means at all. And it's only because your mass always stays the same wherever you are, but your weight can change depending on gravity and things like that. So the relative masses of these 3 ingredients, what you need to know. So if I'll do a little table. I'll do protons, that's P, neutrons, that's N, electrons. Is that even an E? No. Is it? Yeah, that's an E, isn't it? Okay, so their mass, their relative mass. So what do they weigh? We're not really supposed to say weight. Compare in relation to each other. You've got to know that protons have a mass of 1. That's it. Protons have a mass of 1. Neutrons also have a mass of 1. Electrons, that's the only one that's a bit different, is basically 0. All right. For WJEC, it's not going to expect you, especially GCSE, it doesn't expect you to know the mass. It's like 1 over something, but basically 0. And the reason we can't say 0 is because nothing, like everything weighs something. It's just, if you were to compare the weight of the electrons compared to the weight, the mass of the protons and neutrons, it would basically weigh nothing. It's a little bit like you've got the Earth and the mass of a fly on the edge of the Earth is basically nothing. But you can't say nothing because the fly does weigh something, all right? So protons have a mass of 1. Neutrons have a mass of 1. Electrons have a mass of basically 0, okay? Does that look like a 1? I've smudged it there. And that's it, really. I have seen maybe in the old the old test a bit more, where they give you parts of this table and you've got to fill it in. Next thing is relative charges. So positive, negative or neutral, if you've heard of those before. Or you could, I'll show you another way to do it. So protons, listen to it. Now, all 3 of these ingredients, these subatomic particles, have a different charge. None of them have the same. So 2 of them have the same mass, but none of them have the same charge. So 1 is positive, 1 is negative, 1 is neutral. Listen to this, protons. Which one does that sound like, protons? To me, I can hear that that's positive, positive. So you can write positive in there and get the mark. I can't see, sorry. because I've got a flash on there. Or you can write +1. Has a charge of +1, a positive charge. They will accept either or. Neutrons. Now, so we've used positive for protons. We've got neutrons. What does that sound more like? And some people will go, oh, negative N and N. But neutrons are neutral, which means they have no charge. So you could either write neutral or a 0 for the charge. Hopefully the writing's not too terrible for you. Now, I told you that they've all got a different charge. So if protons are positive, neutrons are neutral, then what have electrons got to be? Negative. So I'll write negative there. And they're negative in relation to each other by -1. So these are the relative charges and these are the relative masses. And you do need to know these, foundation or higher. It's a nice question if you can remember. So if really here, the masses, the relative masses, if you can remember that everything that lives in the nucleus has a mass of 1, which is the protons and neutrons. And then the electrons, like little flies whizzing about, because they whiz about in the shells, don't they? They have a mass of basically 0. Okay, and that's it for this video. Hopefully you feel clearer about that. Any questions, ask them in the comments below, and I'll see you next time. Thank you.